All right, this is our first review packet. This one is a multiple choice packet, and let's just see uh, how far we can get through this in the first video. So, what is the limit as h approaches 0 of the cosine of 3 pi over 2 plus x minus cosine of 3 pi over 2 all over h? This should look kind of familiar to you. This is way back from the beginning of the year. This looks like the difference quotient, doesn't it? The limit as h approaches 0 of f of x plus h. That's f of x plus h. That's f of x all over h. And what is this the definition of? This is the limit definition of a derivative. Remember, before we learned any of our rules, we said, oh yeah, that's going to be what f prime of x is. Now, in this case, it's not f prime of x. It's f prime of, I can see what we're plugging in, f prime of 3 pi over 2. And I can figure out what that value is because I can also see what f of x is. F of x is the cosine of x, and we're plugging 3 pi over 2 into it. Okay, so if f of x is cosine x, then f prime of x is negative sine x, and f prime of 3 pi over 2 is negative sine 3 pi over 2. And you should know from your pre-calc unit circle days that sine of 3 pi over 2 is negative 1. So this is negative negative 1. So the answer is positive 1. Okay. At which of the 5 points on the graph in the figure at the right are dy dx, the first derivative, and d squared y dx squared, the second derivative, both negative? So if dy dx is negative, it means that the graph is decreasing. And if the second derivative is negative, it means that the graph is also concave down. So we're looking for the decreasing concave down section, which looks like that right there. So that's got to be point B. Next problem. The slope of the tangent line, the slope of the tangent to the curve, this crazy thing, equals 6, at 2, 1 is. So we need to take the derivative with respect to x of both sides because this equation is not easily solved for y. Now, I'm showing all of my work here. Remember, this is that's probably not correct notation. This is a multiple choice packet, so you can kind of, for multiple choice problems, you don't have to be as formal on your work. Okay. We need product rule here. So, and maybe I could, well, no, I don't think I thought about factoring this out, but I don't think that's going to save me any time. So if I product rule this first part, it's first times derivative of the second plus second times derivative of the first. Remember to chain rule here. The derivative of y to the third with respect to x is 3y squared dy dx. Plus power rule again here. So first times derivative of the second plus second times derivative of the first with chain rule equals the derivative of 6, which is 0. Now remember, you want to keep your dy dx's on one side and move anything that's not to the other. The reason we keep dy dx's together is because we can factor a dy dx out. So this is like, I'm going to write this as 3xy squared. I don't know why I wrote it small like that. Sorry, 3xy squared plus 2x squared y equals, what would be over here? So I'd have to move stuff over here. So negative y to the third minus 2xy squared. And remember, we're plugging in a point, so you don't need to go crazy about like factoring or simplifying or any of that. It's just going to be negative y to the third minus 2xy squared divided by the parentheses. Let's assume these are all non-calculator, by the way, until I think it switches in the packet. So this whole first section is non-calc. And then we are supposed to evaluate that at the ordered pair 2, 1. And remember, 2 is x and 1 is y. So we just carefully plug this in. So negative 1 to the third is negative 1 minus 2 times 1 squared over 3 times 2 times 1 squared plus 2 times 2 squared times 1. So what is that? That's -1 minus 4 is -5. This is 6 plus 6 is 12. Oh no, 6 plus 8. There we go. 6 plus 8 is 14. I was going to say, my answer is not in here. So -5/14. Now, if I'm in a time crunch and I said it was -5/12, I would have still picked C because I would have kind of said, well, that's the closest that I have, and starred this and then come back to it later, knowing that I probably just made a computational error somewhere. Okay, on to the next page. For number 4, this says, let S be the region enclosed by the graphs of y equals 2x and y equals 2x squared for 0 to 1. What is the volume of the solid generated when S is revolved about the line y equals 3? So again, we might need to do things without our calculator. For this problem, we're just picking out the correct setup. So we should be able to do this without our calculator, right? We have 0, 0, even though this chapter we relied on a calculator a lot. 0, 0, they're both 0, 0. When I plug in 1 into 2x, I get 2. When I plug in 1 into 2x squared, I also get 2. So 2x is just a line. 2x squared has that curve to it. It is going to be below because just think about some values here. Like when you plug in 1/2, you're going to get 2 times 1/4 versus 2 times 1/2. So the line will be above the parabola if you're not sure. And then we're revolving this around the line y equals 3. So 3 is up here. If you go along the line at y equals 3, there's going to be this outer r. Capital R is 3 minus the 2x squared function. And then there's this empty space for the washer method. The lowercase r is 3 minus the line, which is 2x. The integral needs to go from 0 to 1. So let's see, pi 0 to 1. So I'm already knocking out the last two choices because they go 0 to 2. And then remember, the integral is going to be from 0 to 1, pi capital R squared minus r squared dx. So I'm looking for the correct combination there. So 3 minus 2x squared squared. That's already knocking it down to a. The other one's 3 minus 2x squared. So you do have to watch and kind of be careful there. All right, so A should be the correct answer. Notice on B, they just switched it around. And on C, I don't know what they did. Oh, they didn't include the 3. Okay, number 5. Which of the following statements about the function f of x equals x to the 4th minus 2x cubed is true? There's no relative max. These are all about points of inflection in relative extrema. So let's go ahead and find f prime and f double prime. So f prime of x would be 4x to the 3rd minus 6x squared. And what would f double prime be? F double prime would be 12x squared minus 12x. So let's just see if about points of inflection and other things. So let's find, first let's find relative extrema. So I can factor out a 2x squared, and that would leave me with 2x minus 3. X equals 0, x equals 3 halves. Remember, these are just critical numbers, so we would need to plot them on a number line and see what's happening with f prime. Now, f prime was a 4x cubed graph, and the graph should bounce at 0 and cross through at 3 halves. So I know that it goes like this, and then it's got to kind of touch and turn and come back here. So it's negative, negative, positive. So there's only one relative minimum. There is no relative max for the graph of f. So let's go through our options here. 2 relative extrema, no, it's not none. 1 relative extrema, 3, 2. So I believe it's got to be C. I don't even need to bother with the point of inflection. If I've got time to come back, maybe I star this and just double check that there are 2 points of inflection, but I'm not going to worry about that now. All right, if f of x equals sine squared of 3 minus x, then what's f prime of 0? So remember, f of x, I want to rewrite this a bit because there's a lot of chain rule happening in here. When they say sine squared, it means the outer function is something squared. Then there's a sine function. and then there's a 3 minus x. So you should be taking derivatives of all three of these things. So the derivative will begin with 2 times sine of 3 minus x. So I took care of the power rule. Then what's the derivative of sine? Let me move this over so my work is out of the way. I'm going to put this here. Okay, so then what's the derivative of sine? Cosine. And what's the derivative of 3 minus x? Negative 1. Now we're supposed to plug 0 into this. I'm not going to go through and simplify anything. I'm just going to say, what do I get when I plug in 0? I get 2 times the sine of 3 times the cosine of 3 times negative 1. So is that an option? So negative 2 sine 3 cosine 3. That looks like option B. Which of the following is the solution to the differential equation dy dx equals 4x over y, where y of 2 equals, this says negative 2. That says negative 2. All right, so this is a separate, integrate, celebrate problem. Then we have something to plug in to figure this out. So separate first, multiply y to the dy side, multiply dx over to the x side. Now we can integrate. The integral of y is y squared over 2. The integral of 4x is 4x squared over 2. So that's just going to be 2x squared plus c. I like to plug in my initial condition right here. So when I plug in 2 for x, I get negative 2 for y. So negative 2 squared over 2 equals 2 times 2 squared plus c. So now this is 4 over 2, which is 2. This is 2 times 4, which is 8. So if I subtract, I get c equals negative 6. Okay, and then if I go back and plug that in, y squared over 2 equals 2x squared minus 6. Solve this for y. Y squared equals 4x squared minus 12. I see a couple of options with 4x squared minus 12. What's the difference? A minus versus a plus. So how do we decide this? Because technically there's a plus or minus when you square root. Excuse me. Go back to the initial condition. When I plug in 2 for x, I'm supposed to get negative 2 for y. So y has to come out negative, which means your square root has to have the negative in front. So it's option C. All right, next page. What is the average rate of change of the function given by f of x equals this on the closed interval 0 to 3? Average rate of change, that's just, go back to pre-calc, that's AROC. The formula for that is f of 3 minus f of 0 over 3 minus 0. Remember, this is just average rate of change is just the secant slope between those 2 points. So when you plug in 3 to the 4th is 81 minus 15. Minus plug in 0, that's 0, divided by 3. So let's see, 81 minus 15. So 81 minus 10 is 71. 71 minus 5 is 66 divided by 3. So I'm getting 22. For number 9, the position of a particle moving along a line is given by this. For t greater than or equal to 0, excuse me, for what values of t is the speed of the particle increasing? Speed is not velocity, remember. Speed is increasing anytime the v of t and a of t signs match. So let's find our velocity and acceleration functions, and then let's see where they are positive and negative. So, and they give us intervals to look at here too. So I can find v of t by taking this derivative. So this says 2t to the third. So this is going to be 6t squared minus 48t, excuse me, plus 90 plus 0. And then a of t is going to be 12t minus 48. And we can factor this. Like I can factor a 6 out. Let's make life a lot easier. That gives me t squared minus 8t. Let's see. 6 goes into 9 once, which leaves me with 30. So then that's 15, right? This factors really nicely. t equals 3 and 5. Toss that on a number line. V of t is a positive t squared graph, so it looks like this. So it's plus, minus, plus. And then what's happening with a of t? So set this equal to 0. I can factor 12 out. I guess I could just solve, couldn't I? But whatever. This works too. So t equals 4. So the a of t graph is just linear with a positive slope. So it looks something like that. So it's minus and then plus. All right, so where is the speed increasing? So merge these two together. So 4. So a of t is negative and then positive past here and negative here. So where do we match? Here and here. Velocity and acceleration are negative between 3 and 4, and they're both positive after 5. So the speed is increasing. They're working together, not against each other on those two time intervals. All right, what about number 10? The integral of this is equal to what? So remember, you can't integrate each separately. What we would need to do is distribute this. Like you can't just integrate this times the integral of that. That's not a thing. So let's rewrite the integral first of all. X to the first times x to the 1/2 is x to the 3/2. Minus 1 times x to the 1/2 is minus x to the 1/2. If I write it in this form now, I can do my power rule stuff. So add 1 to this exponent and you get x to the 5/2 divided by 5/2 times 2/5. It's already this one, right? You can confirm, add 1 to this, you get minus x to the 3/2. Yep, over 3/2 plus c. So it's got to be d. For number 11, now this one, we have not talked about L'Hopital's rule yet, so this is a little more challenging for us at this point. So what is this limit? Oh, no, I'm sorry. We don't need L'Hopital's. We can look at, well, yeah, we do kind of need to look. L'Hopital's to make this easier, but again, that's a chapter 8 thing that we'll look at later. But this is just a limit at infinity. Oh, no, so I don't need L'Hopital's. I'm going crazy. Okay, anyway. Limits at infinity are asking what's the horizontal asymptote if you have a rational expression. So this is x squared over x squared, so it's a tie. The horizontal asymptote is dividing those coefficients. It's 1 divided by negative 4. That was silly of me, so I don't need L'Hopital's. All right, take a look at 11. The figure above shows the graph for 5x minus x squared and the line y equals 2x. What is the area of the shaded region? So that's not too bad. Where do these intersect? They don't tell us that. So we need to solve. One is 2x equal to 5x minus x squared. All right, I'm going to say subtract 2x over, so 3x minus x squared. Do a bit of factoring here. If you factor an x out, you get 3 minus x. So yeah, they intersect at 0 and 3. So now I know that's 3. So the area is the integral from 0 to 3 of top minus bottom. So 5x minus x squared minus 2x dx. And since this is still no calculator, I'm going to simplify that. So that's 3x minus x squared dx. So this becomes 3x squared over 2 minus x to the third over 3, going from 3 to 0. This is 3 times 9, so 27 over 2 minus 27 over 3. 27 over 3 is 9, minus 0. 27 over 2 minus 18 over 2 is 9 over 2. So I am getting, I'm getting B for this one. Number 13, if y equals 5 plus the integral from 2 to 2x of e to the, that says negative t squared dt, which of the following is true? So we have different values for dy dt and then different points here. So first let's find dy dt, or dy dx, excuse me. So dy dx, if I take the derivative of this, the 5 is 0, the derivative of this becomes e to the negative, plug 2x into that, so negative 2x quantity squared, and remember, you have to take the derivative of 2x. This is the second fundamental theorem of calculus, where we take the derivative of an integral. Okay, so that is 2 times e to the negative 4x squared. So that eliminates options A and B and C, right? These have a 2 in front. It's hard to see, but these have the correct derivative. So now it just comes down to the point y of 0 equals 5. So now go back to y. So either y of 0 equals 5 or y of 1 equals 5. So let's try y of 0. So that's 5 plus the integral from 2 to 0 of e to the negative t squared dt. Is that equal to 5? It doesn't quite seem like it. Let's set up the other one before we do any math on this. Y of 1 would be 5 plus the integral from 2 to 2 times 1. This one is something I can do easily. Is that equal to 5? Yes, because the integral from 2 to 2 of it doesn't matter what is 0. So that one's definitely true, so I'm not even going to worry about this one. So it's got to be E. This one I know is not 5 because think about, this graph is something that's not equal to the x-axis, right? Like it's got some area above the graph. So when we go from 0 to 2 or 2 to 0, we're going to get a number that's not 0. So anyway, this page, a slope field. Okay, so which of the following is a slope field for this differential equation? So remember, you can do this by saying, you don't have to actually figure out what the y equation is. You can just say, okay, so when x is 0, I should get horizontal slopes, right? So when x is 0, I'm looking for horizontal slopes. So that's C fits that bill, and D fits that bill, and E. So I have eliminated A and B. And then when y equals 0, I should have vertical slopes. So when y equals 0, that's along the horizontal axis. So, do all of these fit that bill? It looks like all of these fit that bill. Okay, so that's not very helpful. So then what about when x and y are the same? Then I should be getting 1. So when x equals y, I should have a slope of positive 1. So that would be in the first quadrant and in the third quadrant, right, where they're equal. So let's check that. First quadrant, they're not 1 here, so that's out. First quadrant, they're not always 1 here. No, but here that fits the bill. Here's 1 and here's 1. So it's got to be E. All right, now we are allowed to use a calculator for this section. Now, I have a big skip on number 16. So I will come back to this. We can talk more about this, but I will come back to this, but I don't have anything on our exam like this. But obviously this came from some sort of AP problem. So I'll talk about it at the end of my last video for this packet. But we will do number 15. And again, we can use a calculator now. So make sure your calculator's in radian mode. All right, a particle travels along a straight line with this velocity. Measured in meters per second. What is the total distance in meters traveled by the particle from 0 to 2? So total distance is the integral from 0 to 2 of the absolute value of v of t dt. If it said change in position, I would just take the absolute value out. So let's go ahead and calculate this. So this is math 9, 0 to 2. Absolute value, I go to the math menu and over to number. It's also somewhere up here, alpha, one of these. Oops, I put it in the totally wrong spot though, so get this back. So math, number, absolute value. Okay, and then v of t is 3 e to the negative x over 2 times sine of 2x. Do a quick check that I typed that in correctly. And do we see this answer? Yeah, 2.261. Okay, so again, skip this until the very end of my last video if you're curious about this one. Let's see. Number 17, the graph of the function f is shown above if the limit as x approaches b of f of x exists. So that means that both sides approach the same value. And f is not continuous at b, then what does b equal? So that's an example of like here, the limit exists, but the graph is continuous here too. But here, the limit exists. The limit is 2, but the graph is not continuous because the actual value jumps down here. So b is 0. Because otherwise, the limit doesn't exist at -1. Limit doesn't exist at 2. Limit does exist at 3, but the graph is continuous. And same for 1. All right, number 18. Let f be a function such that f double prime of x is less than 0. So that tells me the graph is concave down. For all x in the interval between 1 and 2. Selected values of f are shown above. What must be true about f prime of 1.2? So I can see that f is, so even though we have a concave down section, which means that f prime is decreasing, I can see that the values for f are increasing, right? So f is increasing, which means that f prime is positive. I also know that even though f prime is positive, f prime is decreasing. So what is this telling me? So f prime of 1.2 is less than 0. That's not right. I just said it's positive. F prime of 1.2 is between 0 and 1.6. So, well, I don't know. Let's see what these average rates of change are. So I'm looking at the average rate of change around 1.2. 4.56 minus 4.18 divided by 1.3 minus 1.1. So the average rate of change here is what did that just come out to? 1.9. So that's telling me that f prime is, do I know it's between 1.8 and 2.0? That fits that. All this extra stuff that I found, though, didn't really help me with the other stuff. So I think that's got to be it. I know that it's not greater than 2. Yeah, and 1.9 is the only one that falls between these other two. So I think it's got to be D. I guess I didn't need the fact that I knew f prime was decreasing. The positive thing helps me, but nothing else really. I could probably also find like the whole rate of change there, but I don't think that's going to help me narrow down answers anymore. Okay, number 19. Two particles start at the origin. They start at 0, 0, and they move along the x-axis. From time 0 to 10, their respective position functions are given by x1 and x2. For how many values of t do the particles have the same velocity? So I should find velocity 1 and velocity 2 and put them in my calculator and see where they intersect, right? So velocity 1, the derivative of sine is cosine. And velocity 2, the derivative of e to the negative 2t is e to the negative 2t times negative 2. So let's put those in our calculator and see where they intersect. So cosine of x and negative 2 e to the negative 2x. And they gave us a window 0 to 10. And then we're going to zoom fit. So I see 1, 2, 3. I see 3 intersection points. All right. I think we can get a little further in here. Let's see. How many problems are there? Oh, we can finish this, I think, before class starts. So let's see. All right. So number 20. The graph of the function f shown above consists of two line segments. If g is the function defined by the area from 0 to x of f of t dt, then what is g of negative 1? So g of negative 1 would be the integral from 0 to negative 1 of f of t dt. We know that we have to turn that around by putting a negative out in front, make it negative 1 to 0. So negative, and then what is this area from negative 1 to 0? It's a positive area. It's 1/2 the base, which is 1, times the height, which is 2. So that positive area is going to become negative because of the negative that I put out in front. So that's an area of negative 1. So I got B. For number 21, the graphs of 5 functions are shown below. Which function has a non-zero average value over the closed interval from negative pi to pi? So the average value, remember, is, so we're saying like 1 over 2 pi, right? Pi minus negative pi, times the integral from negative pi to pi of the function is not equal to 0. So 1 over 2 pi is not equal to 0. We just need to look at, so we just need something whose net area is not 0, right? Like this net area is 0. This net area is 0 because you have the exact same positive and negative areas. This area looks like this negative section plus this negative section adds up to the same here. Same thing with this one. But here, the area here does not compensate for all this negative area here. So it's got to be E. All right, last page of problems here. So a differentiable function f has the property that f of, this says f of 5. Sorry, I don't know why it's scrunched like that. Hopefully your paper's better. F of 5 equals 3 and f prime of 5 equals 4. What is the estimate for f of 4.8 using the local linear approximation? That just means tangent line approximation for f at x equals 5. That means come up with the tangent line and then plug in 4.8. So our point is 5, 3. Our slope is f of prime of 5 equals 4. So it would be y minus 3 equals 4 times x minus 5. Plug 4.8 into that. Plus 3. Remember, we have a calculator, so even though we should be able to do this without, I'm taking the lazy way out so I don't make a silly mistake. 2.2. All right. Related rates. Oil is leaking from a tanker at a rate of R of T, gallons per hour, where T is measured in hours. How much oil leaks out of the tanker from 0 to 10? So that's just the integral from 0 to 10 of R of T dt. That'll tell us how much leaks out. So math, 9, 0 to 10, 2,000 e to the negative 0.2x dx. 8647, I guess we're going to go with D. And last problem, f prime equals this, f of 0 equals 1. What's f of 2? This is a fundamental theorem problem. This says I should be able to start at f of 0, add the change in position from 0 to 2 of f prime of x, of the integral of f prime of x dx, and that should land me at f of 2. So 1 plus this integral is equal to whatever f of 2 is. So 1 plus 1 plus math, 9, 0 to 2, of the sine of pi. Trying to hit pi. Oh, my pen died. Hold on. Pi. Okay. Pi. There we go. Pi. E to the x. Divided by 2. I'm getting 1.157. So that's option E. And, I guess we have, I don't have answers down here on mine. I don't know if you have answers on yours. But I think on the key that I posted, I believe the correct answers were down here. So hopefully I matched all of my correct answers there. All right, if you have any questions on this, feel free to stop by office hours. Hopefully this was a good little practice on some multiple choice questions.